We now have our neural network and we have our loss function. Now let's create our optimizer. So this will be from the torch.optim module. And then what we're going to get from that module is going to be SGD for stochastic gradient descent. And a lot of times when we create things from PyTorch, we don't have to give any inputs to the creator, but here we do. We need to say, what are the parameters that we're trying to optimize? So in this case, the parameters are the weights and bias from the neural network. So I use model.parameters. And maybe there's a default for this, but it's at least good practice to always specify a learning rate, which is like saying, how much of a change do you want to make at each step in this optimization process? And I have no idea what a good optimization learning rate is for this particular problem. Let's try 0.1. And I see I forgot to save it. Let's call it optimizer, okay, for the variable. And let's go through each parameter among our neural network's parameters. And instead of saying print p, well, let me do that, but let me also print p.grad, okay, for gradient. And let me also get a line break by just printing an empty string. And so the first iteration through the for loop, okay, it's printing the weights, and then it prints none. So that's saying so far there's no gradient. And similarly for the bias, there's no gradient. Okay, that's fine. Let's now, we still have this loss up here. And let me save that. And the key thing is that it's just a single number. Okay, here it's 0.7162. It can be thought of as a scalar. And I'll save this as loss. And then let me say loss.backward. And in theory, maybe I'll do this anyway, even though we don't need to. It's a good practice to be in to, before you run backward, to reset the gradients for the optimizer. So I'll say optimizer.0grad. Okay, we didn't need to here because they were none already, but in the future that'll be important. So let's run that. See if it works without an error. And this backward, that's like saying, for the loss computation, compute its gradient. Okay, compute the gradient with respect to the variables weight 0, weight 1, and bias 0. Okay, and let's try running this exact same for loop again. So you can see that now we have some gradients, and these gradients can be used to adjust the parameters of the model. So for example, if I type optimizer.step, that says use this stochastic gradient descent optimizer and use these gradients here. Use them to change the values of the weights and the bias. If for a bigger neural network, there'll be many biases, but here there's just one. So let's try this again. And so have they changed? Let's see. So we wouldn't expect the gradients to change because I haven't done any extra computations for the gradients. So those things that I'm highlighting have not changed. But what about the other ones? Yeah, this has changed from 0.24 to 0.26. Okay, and this one's changed from negative 0.21 to negative 0.18. And overall, that looks pretty good. So I think I might have chosen an appropriate learning rate. And in the next video, we'll put this whole procedure into a for loop to try to find better and better choices of parameters for this model.